Greetings, Saintsman. I got an additional video for you here for 9.6. First thing I want to just discuss is a couple word problems that we're going to utilize. So first thing, let's talk about fantasy of mine, which is to have a motorcycle. It's a fantasy that unfortunately Mrs. Granados pretty much shut down for the remainder of my life. But talk about getting a, when you have a pickup truck like I have, some of the things that people, like always wind up doing when you have a truck is they always ask you to move. They always ask you to haul things for them. But the other thing they're handy for is they're actually pretty handy to move motorcycles. So as much as I wish I had a motorcycle or something fun like that, some of you guys may have motorcycles. I only just dare to dream. Well, let's talk about how fun it would be to put a motorcycle in the back of my truck. So we're going to take the tailgate of my truck, which has a 10-degree angle of depression to a motorcycle ramp. Okay, if the tailgate is 3.5 feet off of the ground, and how long is the ramp? Okay, these are actually like pretty reasonable questions, right? 10 degrees. And here's the thing is that we're going to have to draw what this is. So we're going to draw the tailgate of my truck, okay? And it's not going to be that fancy of a drawing. Here we go. That's it, right? So this is, the back of the truck, right? The tailgate actually folded down, and this is like some horizontal distance here. You're right into that edge, which is going to be about 3.5 feet. And then we have, of course, the ramp itself, right? And then we have it on the ground. And then here is that line of sight we've discussed previously. Now, this is your 10-degree angle of depression, okay? What we want to know is this value X right here, the length of that ramp, which is a reasonable question, right? Like, can you fit that ramp in the back of your truck? Can you store that in your garage, etc.? Something to keep in mind is that, thinking about this, from this line of sight up here, right, down to the ground right here, these two lines are going to be parallel, meaning that this motorcycle ramp is effectively going to serve as a transversal. So this angle of elevation simultaneously winds up being 10 degrees because these angles, the angle of depression and the angle of elevation, are alternate interior angles. So let's actually do this problem here. So let's say from the angle, right? So here we are in our triangle. We have 10 degrees. From this angle, the sine, right, of 10 is the opposite, right? Opposite 10 degrees is 3.5 over x, which is what we're trying to find here, the length of that motorcycle ramp. So it's going to be a pretty straightforward problem, right? We're going to swap here. You wind up multiplying by x on both sides, right? Factors out. And then I have x times the sine of 10 is equal to 3.5 divided by the sine of 10, right? Sine of 10 is just a number. And then now x is by itself, which is equal to 3.5 over the sine of 10. And that is your answer. Now, of course, we're going to punch that into our calculator to get an approximation, right? Which, because you're not going to find 3.5 divided by the sine of 10 on your calculator, right? Or not on your calculator, but on a tape measure, as you're, like, what's the length of this motorcycle ramp? So you actually have to look here, and this is going to be about 20.16 feet. Okay. Another way to go about this problem, of course, again, right here, this angle right here, this is going to be 80 degrees. We could, of course, use the cosine of that 80 degrees, right, is going to be the opposite, or the adjacent 3.5 over that side, or that hypotenuse x. Excuse me. So just things to consider. I think some of you guys have also seen this pattern here when anytime we have something like this where we have the sine of an angle is equal to a length over the a variable, is that effectively these two terms, because this guy is this over 1, they're effectively going to swap spots. So this winds up just being 3.5 over the sine of 10. something to keep in mind. All right, a little bit of throwback for you guys for the next and the last word problem. Let's talk about the old school. So, two hypothetical students. Doesn't matter, right? Name them common names, right? Not like I have any students that are named this. So we'll take the student Billy and another random kid, Riley, right? You've probably met one of those once upon a moon. But Billy and Riley, pretty cool kids. They're standing at a cliff. Sorry, excuse me. To decipher where they are on this cliff. It's going to make all the difference mathematically, as well as for the sake of their safety. But they're sitting at the bottom of a cliff. You guys remember the following game. Playing Pokemon Go. You guys remember there were actually some tragedies with Pokemon Go with kids that as they were finding, they were searching for these Pokemon in random parts of wherever and sometimes falling because they were in dangerous places in nature. So they were trying to, get, whatever those things were, some of the, whatever the Pokemon, fancy Pokemon are. I don't know. I actually wasn't into the game. But it looks like these kids, Billy and Riley, are. So, there is a Pokemon at the top of the cliff. They're standing 15 feet apart, something that they could easily measure, right? Their angles of elevation, right, are 60 degrees and 40 degrees, respectively. So how high up is the Pokemon? Now here's where we're going to have to draw some pictures, okay? So we can draw these guys, kind of a waste of our time though, right? We're going to have some triangles that we're going to need to draw, right? So we have the ground, we have this cliff that goes up, right? And we're going to have the two kids. And the idea being is that there's some altitude. And they're 15 feet apart. So I'm going to have another line of elevation right here, right? So this distance between these two kids is 15. I have no idea which kid is which, Billy and Riley. I know that there's Billy's 60 degrees off and Riley's 40 degrees off. Now, aside from the fact you guys are just looking at these, right? And you're trying to decipher, well, which one is 60 and which one is 40? Okay? How could we prove that? Well, thinking about this, that if this side here, right, is going to remain the same in each of these triangles, thinking about the angle side relationship, as this side is going to increase, right, because of the angle side relationship, this angle here is going to increase, meaning that this angle here has to decrease as it moves out, right? So the lesser angle is going to be 40 degrees, and the greater angle, of course, is going to be 60 degrees. So again, the 60 degrees, respectively, is referring to the first person. That's this rando Billy. And then Riley, the other, whoever he is. All right. So, at the top of the cliff, the Pokemon, whatever Pokemon it is. I can't even think of a Pokemon name. The question is, how high up are they going? Okay. How do we find this? So, there's two distances here. And here's where the algebra is going to come in. This is some distance. First of all, we don't know how far Billy is from the edge of the cliff or how far Riley is. We just know that they're 15 feet apart. So Billy is like some value X and Riley is going to be some value Y. Okay? So let's set up two pieces of two trig functions here. And we're going to have to get these things in terms of each other and hopefully in the terms of the same variable. Because right now we have triangles in two variables. So let's take Riley's position here. So Riley, they would figure out him to the Pokemon. He's going to be the tangent of 40, right? Because it's going to be the opposite over the adjacent side. So the opposite Riley is going to be Y. And the entire adjacent side isn't 15, but it's 15 plus X or X plus 15. Okay, now think about this triangle here. From the angle where Billy's at, we have the tangent of 60, right, is the opposite over the adjacent. So that's going to be y over x. Now, watch what we're going to do here. We're going to solve each of these guys for y. Because when we do that, both of them will be equal to y, and then we can make these two expressions equal to each other, and then we have an equation in one variable. So we'll do this through a system of equations. So I'm going to multiply here and get rid of this x plus 15 on the bottom. Multiply both sides plus x plus 15. So this quantity times the tangent 40 is equal to y, right? Multiply this guy by x over here. So we have x times the tangent of 60 is equal to y. Again, our goal was to get these both equal to y. Therefore, they equal each other. X plus 15 times the tangent of 40 is equal to x times the tangent of 60. Okay? Step next is we're going to have to distribute, right? Because remember, tangent of 40 is just a number. So we're going to distribute this thing into both of these. So we're going to have x times the tangent of 40, right? Some decimal number, plus, because tangent of 40 is just a number, 15 times the tangent of 40 is equal to x times the tangent of 60. Now, let's move all the terms that have an x in it over to one side, so they're all collected together. So next step is I'm going to subtract x times the tangent of 40 from both sides. All right, so that guy cancels out. So I have 15 times the tangent of 40 is equal to x times the tangent of 60 minus x times the tangent of 40. Now, both of these have an x in it. It's this, guys. We're going to have to undistribute this. Imagine we had a times b minus a times c, right? Can't that factor the a out and then we have a b minus c, right? Because think about this, you could redistribute it. A times b is ab, a times negative c is negative ac. So the same deal here, 15 times the tangent of 40. We're going to pull that x out, and that way we can get the tangent of 60 minus the tangent of 40, whatever those two numbers are, inside the parentheses. Now, we can now solve for x, right? So we're going to divide both sides by this entire quantity. The tangent of 60 minus the tangent of 40. Right? Factors and factors. So 15 times the tangent of 40 over the tangent of 60 minus the tangent of 40 is equal to x. Boom. We are done, gentlemen. We now know what x is equal to, right? Pretty straightforward. That's some number, okay? So what does that even mean? We have this value right here. We need to figure out how high up y is. So what do? Well, we know what y is. It's this, right? Isn't y, and bring this guy back down, wasn't y equal to x times the tangent of 60? But this is what x is, so I can plug that in right here. So y is really going to be equal to this entire quantity, 15 times the tangent of 40 times the tangent of 60, right, all over tangent of 60 minus the tangent of 40, right? This is like tangent of 60 over 1. So this is going to be equal to 15 times the tangent of 40 times the tangent of 60 all over the tangent of 60 minus the tangent of 40. This is the height of the cliff. All right? Now, we have to punch that into a calculator. So let me grab a calculator real quick, because I actually don't have that calculated in front of me. So let's get a calculator. All right. So, so we have 15 times, oops, let's see, tangent of 40. So 40 times. Oops. Goodness gracious, guys, I'm having a hard time. And you know what? I have a computer calculator, but I don't have my my regular scientific calculator, my regular whatchamacallit, graphing calculator is actually stuck at school. So you know what? When you guys come and see me in class, I'll actually have the real approximation for this. But this is actually the correct answer. This is what I need, and then you can punch in the calculator and give me an approximation. But this is exactly it. Okay, we'll put this thing in terms of feet that you'd be able to measure with a ruler shortly. So do more of these in class. Good luck.